Hello everyone, welcome back to Romanian Math Club. Today our question is y to the power 4 plus y squared is equal to 20. So here we have to find the value of y where y is belongs to real number. So now here this y to the power 4 can also be written as y squared whole squared plus y squared, and if we just shifting this plus 20 we get minus 20 is equal to 0. So now here we can also write this y squared like as that suppose this y squared is equal to k. So putting here then we get k squared plus k minus 20 is equal to 0. So now k squared plus k minus 20, here it is a nice quadratic equation. So we have to solve this, and here we just write these plus k, just splitting this plus k into factors. So we just solve it by using factorization method, and here we know that this plus k is equal to plus 5k minus 4 times k minus 20 is equal to 0. Here plus 5k minus 4k, it will be equal to plus k, and 5 times 4 is 20. So these are nice here pairs of this 5k and minus 4k. So if we just take common here k, we get k plus 5, and if we take minus 4 is common, so we have k minus time minus is plus, and by dividing this 20 by 4 we get 5, so it is equal to 0. Now we have two possible factors here, that is this one is common, k plus 5 times k minus 4 is equal to 0. Now k plus 5 is equal to 0 and k minus 4 is also equal to 0. So here k is equal to minus 5 and here k is equal to 4. So we know that the value of k is y squared is equal to k. So putting here then we get y squared is equal to minus 5. So now taking square root on both hand side here, similarly on our right hand side, so cancelling square with square root, we get y is equal to plus minus square root of this 5 can also be written as square root of 5 times square root of minus 1. So here y is equal to plus minus square root of 5, and we know that minus 1 square root is equal to iota, which is I. So here we get y is equal to plus minus square root of 5i. But there is no real solution, it is complex solution. Here we have just written those values of y in which that it is given that y is the element of real number. So there is no real solution, hence we are going to reject this value here because it is complex solution. So now if we see our other case, that k is equal to 4, so here y squared is equal to k, and then it will be y squared is equal to 4. So taking square root on both hand side, cancelling square with square root, we get y is equal to plus minus 2. So here we have two possible values of y, which is here plus 2 is real and minus 2 is also real solution. So we have y is equal to plus 2 and y is equal to minus 2. So these are values of y that belongs to real number. So now we are going to check our solution here, that our problem is y to the power 4 plus y squared is equal to 20. So we have to put these values for verification. Now we are going to check our solution here by putting value of y is equal to 2 in our problem. So here in this y to the power 4 will be 2 to the power 4 plus 2 to the power 2 is equal to 20. So now we know that y to the power 4 is equal to 16, and here 2 squared y means 2 to the power 4 is equal to 16, and 2 squared is equal to 4. Here it is 20, so 16 plus 4 is equal to 20, and 20 is equal to 20. So left hand side is equal to right hand side, hence value of plus 2 is true for this problem. Now we are going to put y is equal to minus 2. So when y is equal to minus 2, now our problem is y to the power 4 plus y squared is equal to 20. So putting a value of y, which is minus 2, then we get minus 2 to the power 4, and here plus minus 2 squared, which is equal to 20. So minus 2 to the power 4, it is also equal to plus 16, and here it is plus 4. So here it is 20. 16 plus 4 is equal to 20. So 20 is equal to 20. Hence our left hand side is equal to right hand side. So these two solutions of y, that is, it is our answer, that y is equal to plus 2 and y is equal to minus 2. So these are two possible solutions for y. Now we are going to check our entire solution here step by step. So here we see that it is verification of this problem, and we have just rejected the complex solution here. So it is our whole solution. So that's it for today. Thanks for watching. Have a nice day. Goodbye.